C225.
Oh, you don't have a room right here? No, you can't even do it. Man, why you gotta wiggle wobble all the way down there? Wobble it, wobble it. Put your legs in.
Alright, any questions from yesterday? Worksheet 8.1, any questions?
Oh, well, I can't talk to you. Put my grade, mine.
Alright, did everybody hand it in already? Anybody have it? Pass it up if you have it. Worksheet from yesterday.
Thing what?
The worksheet is
We had a test in. Did I? Did we?
Alright. Let's get started here. Alkenes. They are similar to alkanes, except they have at least one double bond. You could have more than one double bond, but for today, we'll just draw them all with one double bond. Now, yesterday our list started with methane, then it was ethane, propane. Today we'll start with the 2-carbon one, ethene. And there's a reason, and that is that methane doesn't exist. This is not possible, because we can't have one carbon and have a double bond, because there'd be nothing for it to double bond to, right? You can't have a double bond to a hydrogen, because hydrogens only make one bond. So this is impossible. So the first one on our list is going to be ethene. So what I just said will make sense in a second. So imagine here, I'll write the formula in a second, but let's draw it first. We have 2 carbons, and there's a double bond between the 2 carbons. And then what's the rest of this going to look like? How many hydrogens on each side? Nope. Because, yeah, exactly. Because there's 2 bonds already, it has to be 2. So you only have 2 hydrogens attached to the carbon. Carbon only makes 4 bonds, right? That's one thing you have to remember for the next 2 months, is carbon makes 4 bonds. So this carbon has 1, 2, and then the double bond counts for 2, that's 4. Same thing with this carbon. So now, hopefully, you see why you couldn't have it with 1 carbon, right? You couldn't have a single carbon, because what would a double bond to? There's nothing to double bond to. So you have to have at least 2. So ethene is the first one on the list, and that's C2H4. And what's the next one going to be called here? Pro what? Propene now. So they call it propene. And so we're just going to draw 2 carbons with a double bond. I should leave some space here because I'm going to put hydrogens on top. So 2 carbons with a double bond, and then I'll just make a single bond to the other one. I could have 2 double bonds. But for today, we'll just make 1 double bond for each one. So now here's where you got to be careful, right? You go through each of the carbons one at a time. Each carbon can make 4 bonds. So how many does this get? How many hydrogens? 2. What about this carbon? It's only going to get 1, because it's got 2 on that side and 1 there. So already got 3. It's only going to get 1 more. Doesn't matter if you put top or bottom. In 3 dimensions, it would be meaningless anyway. And then this carbon. That gets 3. There you go. So that's propene. If you count the hydrogens, we got 6. So that's C3H6. All right, and let's do butene. So this one's going to have 4 carbons. C, the double bond, and then we'll just put single bonds to the other 2. Yeah, it could have more, and you can still call it butene. First carbon's going to get 2 hydrogens. Second carbon's going to get 1 hydrogen. Third carbon's going to get 2, because we got 2 already. Fourth carbon gets 3. There we go. So that's going to be C4. 1, 2, 3, 4, 5, 6, 7, 8. C4H8. Should I do pentene or should I stop here?
I have one more. Why not?
All right, one more. So pentene, of course, going to have 5 carbons. There'll be 1. Double bond the first 2, and again, it doesn't matter which ones you double bond. Later on, if we get deeper into it, there's a system for describing it. But we'll just always put it on the first one today. Third carbon, fourth one, and fifth one. There we go. 2 hydrogens. I didn't leave myself enough space. 2 on this guy. 1 on this thing here. It's already got 3 bonds. This one's got 2 bonds, so we'll put 2 hydrogens on it. This one's got 2 bonds with 2 hydrogens on it. This one gets 3 hydrogens. And so if you count them up, that's C5H10. So the pattern, if you just have 1 double bond somewhere on the molecule, is that however many carbons you have twice as many hydrogens. And that's pretty much it for the alkenes. They just get longer and the chain just continues the same way. You good with these? All right. Again, in 3 dimensions, they don't look like this, right? Here's ethane, which we learned yesterday. This is single bonds, right? 2 carbons. Here's ethene, and I have to bend my little pieces. You'll use these eventually. So that's that one. And then I'm going to show you in a second ethyne, which is a triple bond there. So now that we're good with these, I'm not sure where I'll start here. This will go here, so I'm going to have to catch up. Well, I don't know. All right, yeah, I'll go here. What's up?
When you do like the double bonds and single bonds, how do you know how the hydrogen?
Okay, so can you see this one clearly?
Yeah.
Okay, so this carbon has a double bond here. So carbon can only have 4 bonds, so I put 2 hydrogens on it. So that makes 4. This guy here, he's got a double bond and a single bond, that's 3. It's 1 hydrogen to get to 4. This carbon has a bond on each side, that's 2. So it gets 2 hydrogens to make 4. This one bond on each side has 2. Those 2 make 4. This carbon only has a bond to the last carbon, so it needs 3 hydrogens to have 4 bonds. So you should see 4 lines connected to every single carbon. All right, well, let's do alkynes. I hope I can see this on the camera. Alkynes. And you can pretty much guess where this is going. These are triple bonds. Like alkanes, but have at least 1 triple bond. And so just like I said before, same thing for alkynes, you can't have a 1 carbon version because there would be nothing for the triple bond too. So methine doesn't exist. Ethine is going to be the first one on the list. C225. Okay. All right, fine. Matthew, they want to see you in guidance. All right, so let's Can I erase you a little bit caught up here?
Yeah.
Alright, let's erase up here. Alright, so we're going to do ethyne first. Okay, yeah. Ethyne, if you care, which nobody's going to care, but ethyne is actually commonly called acetylene. This is the stuff that's in an oxyacetylene torch.
Got
All
the whole
right.
paddle. Possibly. Lesson one.
So here we go. Triple bond between the two carbons. And now, how many hydrogens on each carbon? It's going to be one, right? This carbon has 3 bonds here. It can only have 1 more. This carbon has 3 bonds. It can only have 1 more. That's it. So the formula here is going to be C. I should start writing the formula after drawing. C2H2. Pretty good. Am I going too fast, Randy? Okay. All right. What's the next one going to be called? Propine. That's right. Propine. All right. So this is going to be 3 carbons. So we're going to draw 2 carbons with a triple bond, and then we'll just single bond the other one. Now, you could never have 2 triple bonds in a row because this carbon would have 6 bonds. So this one kind of has to be this way. How many hydrogen on the first carbon?
2.
1. What about the second carbon? None. It's got 3 here and 1 there. It's already full. It's already got its 8 valence electrons. What about this one? 3. H, H, and H. Alright, so that's going to be C3H4. If you like math and you want the formula, remember for alkanes you double the number of carbons and add 2. And then for these you just double the number of carbons. For the alkynes you double the number of carbons and subtract 2. So that's what the formula is. Let's do butane.
You wouldn't add 1.
No, because with this one you didn't add 1. So this will be triple bond between 2 carbons, and then we'll just single bond the next 2. You could have more than 1 triple bond, right? But we're not going to do that today. So how many on the first one? 1. How many on the second? How many on the third?
2.
2. How many on the fourth? 3. Carbon always gets 4 bonds. Alright, so that's going to be C4H6. So if you draw these first, then you'll figure out what the formula is, right? You don't have to memorize. Like if you wanted to memorize it, for all the alkynes, it looks like this. C, whatever the number is there, H, 2 times that number minus 2. You know, so if you want to write a formula down, that's what it looks like. But it's easier, I mean, for this, you know, when you first see these things, if you can draw this, write a carbon, triple bond to the next carbon, single bonds to the rest of them, and then just figure out for each carbon how many hydrogens it gets and just add up at the end. A little bit easier that way. All right, should I do any more? No. All right, we are done. Questions? Alrighty. All right, Mia, do me a favor.